Alright, so in this video, we're going to go ahead and discuss how to find the area or the area of a region between two curves. So what I've sketched here is two functions here. We have y equals x and we have y equals 1/4 x squared. And what I'd like to do is be able to find the area enclosed between these two graphs right here. But before we do that, what I'd like to first figure out is, well, it looks like I'm starting at 0. It looks like I'm starting at 0. And it looks like I'm ending somewhere over here. I don't know what this is yet. And to figure out what these limits are going to be, to figure out where we're integrating from, or where my starting value is and where my ending value is, what I want to do is set these two equations equal to each other to find out where they intersect. So I'm going to go ahead and do that first. So I'm going to have my first equation is y equals x. So I'm going to say x, and then we're going to have equals my second equation. Well, my second equation here is my second function here is 1/4 x squared, and what I can do is move the x over, so I can now have 0 is equal to, say, 1/4 x squared, 1/4 x squared, and then we're going to have minus, because I'm going to take away this x and I'm going to move it to the other side, so it becomes minus x. And then what I can do is factor out. I can factor out an x here. So if I factor out one of the x's, I'll be left with 0 is equal to, let me factor out an x in yellow, and I'll be left with 1/4. Actually, let me keep my colors consistent. I'll have a 1/4 x, and then I'll have minus this x has been factored out, so I'm left with just a -1. And what I can actually do is set each term equal to 0, and figure out where these things actually intersect. So I'll have one solution will be x equals 0, and that's pretty clear from the picture. It looks like they're right at 0. Right at 0 they intersect. To figure out the next solution, I'm going to go ahead and set this whole thing right here equal to 0. So I'll have 1/4 x minus 1 is equal to 0. And I'm going to move the 1 over, so I'll have 1/4 x equals 1. Multiply both sides by 4, and I get x is equal to 4. So it looks like here, this number right here is going to be a 4. So question mark is equal to 4. So it looks like we're going to have to be integrating from 0 to 4. But how do we find this area only? Well, here's what I'm going to do. I'm going to break this up into two different problems. I'm just going to focus on y equals x. If I had just asked you, well, what is the area underneath the curve, all of this, so all of this right here. So what is that area right there? Well, you would say, well, the area is given by the integral of 0 to 4. You would say this, it's given by the integral of 0 to 4 of my function x dx. And what this would give you is the entire area underneath y equals x. Well, what if I asked you a separate question and I said, well, okay, that's great, but now can you just tell me the area underneath the quadratic function? Well, the area underneath, so let's say I asked you the area for underneath the curve of 1/4 x squared. Well, you would then find just this part right here. So you'd be finding this piece here. So how do you find this area right there? Well, again, you would say, well, that's simply the integral from 0 to 4. That would be simply the integral from 0 to 4 of our function 1/4 x squared dx. But again, I'm not asking for the entire area under the blue curve, and I'm not asking for the entire area under the green curve. What I'm actually asking for the area in between these two curves. So how can we figure that out? And hopefully, you have some type of idea of what's going to happen here. What we can actually do is this. Let me go ahead and clear some space here, or erase some of this. Well, no, I'll leave it there. So what I can actually do is I can think about it like this. I can find the entire area underneath my y equals x curve, and that'll give me this whole thing right here in orange and green. So I'll have the orange and green area here. We'll add all that up. But then I can take away the green area. I can actually take away the green area. And if I take away this green area, I'm really taking away this net area right here that I've accumulated, and that'll leave me with the orange piece. So what I can actually do is take this piece away. So I'm subtracting this off right here. And that'll leave me with this area that I really want, right? So we're going to go ahead and do that. So then what I could write is that my area, the area between these two curves, maybe I should call this A1. So let me just get out my pen here. So A1, and maybe I should call this A2, but I could just say that the total area between these two curves here is going to equal, well, it's going to equal the area underneath the first curve, which is 0 to 4 of x dx. But then I have to subtract. I have to subtract the area underneath the bottom curve. I have to take away this area. So it's going to be the area, let's see, the integral, from 0 to 4 of 1/4 x squared dx. And that is, and we can evaluate that, and whatever number I get would be the area in between these two curves. But I want you to get, I don't care too much about evaluating this integral. I'm sure that by now you can go ahead and do that very easily. What I care more about is understanding the concept of being able to sketch a picture and being able to draw and figure out how to set up your integral. We're going to do more problems like these as we continue. In the next video, we'll do one where maybe the area is underneath, or we'll see various examples. So stay tuned for the next video.